For centuries, Mars has captured people's imaginations. From early Mars tracking its movements across the sky to contemporary science fiction that reveals new frontiers for human exploration, Mars has long been the subject of wonder, curiosity, and wonder. More, hopefully. Our passion for the red planet is not just about foreign countries. That's the point, a world far away, close to touch, but too far to miss. This desire within them has led scientists, engineers and visionaries to ask one of the most profound questions: is there life on Mars? And if it is, or has been, what does it mean for life on Earth? Today, with missions like NASA's Perseverance rover and the European Space Agency's ExoMars program, we are closer than ever to answering this question. But to understand where we are now, we must look back at the history of our attempts to explore this enigmatic planet. Before space exploration became a reality, Mars was seen as a world teeming with life, or at least the potential for it. In the late 19th century, Italian astronomer Giovanni Schiaparelli observed what he described as canali on the Martian surface, which was mistranslated as canals. This fueled speculation that intelligent beings on Mars had constructed massive waterways to survive in an otherwise inhospitable environment. These theories were further popularized by American astronomer Percival Lowell, who wrote extensively about Mars, believing it to be home to a dying civilization. Myths like H.G. Wells' The War of the Worlds and Edgar Rice Burroughs' A Princess of Mars added to the myth of a planet inhabited by advanced humans. But as human knowledge grew, Mars became reality for what it was, a cold, dry, barren planet. However, the attraction remained. The real scientific exploration of Mars began with the work of Mariner. In 1965, NASA's Mariner 4 spacecraft made the first successful flight to Mars and took the first close-up images of the Martian surface. These images shattered the romantic feelings of the valleys and tribes. Instead, they found a moon-like surface. However, this discovery did not diminish the fight for life. Instead, he created a more accurate scientific approach to understanding Mars. The Viking project in the 1970s marked the next major leap in Mars exploration. The Viking 1 and Viking 2 spacecraft were the first spacecraft to land on the surface of Mars and conduct biological experiments. One of the main goals of the Viking missions was to find signs of microbial life. The astronauts performed many experiments, including experiments to detect metabolic processes, the presence of carbon molecules and reactions with the atmosphere. However, the results are ambiguous. While some of the experiments pointed to possible biological activity, others failed to identify organic compounds, sparking decades of debate in the scientific community. Despite the inconclusive results, the Viking missions provided valuable data on Mars' atmosphere, soil composition and weather patterns, laying the groundwork for future exploration. After Viking, Mars exploration entered a new era with the arrival of probes and rovers designed to study the planet in unprecedented detail. One of the most important discoveries in recent years is definitive evidence that Mars was once a watery planet. Mars Global Mapper, launched in 1996, provided high-resolution maps of the Martian surface showing ancient river valleys, and lakes. These features show that liquid water flowed onto the surface when Mars had a more temperate and milder climate, perhaps billions of years ago. Rovers such as Spirit, Opportunity and Curiosity have explored these ancient environments, providing direct evidence of water-related minerals such as clay and hematite. In particular, because of the desire to combine the water of Mars. Discovering Gale Crater revealed layered sedimentary rocks that indicate an ancient lake that was once host to microbial life. In addition, Curiosity's discovery of complex organic molecules, albeit in very small quantities, has fueled the debate about life on ancient Mars. These discoveries have dramatically changed the focus of Mars exploration from the search for modern life to the search for evidence of past life. One of the most interesting discoveries in the last couple of years is the presence of methane in the atmosphere of Mars. Methane is a gas that occurs on Earth during most biological processes such as the breakdown of organic matter. However, they can also be produced by Earth processes, such as liquefaction, which occurs when water reacts with certain minerals. Methane was first detected by the European Space Agency in 2003. In 2014, NASA's Curiosity rover made a breakthrough by detecting seasonal changes in methane levels. The fact that the concentration of methane varies with the seasons on Mars suggests a possible biological source, as microbial biomass can produce methane at certain times of the year. However, alternative explanations, such as thermal activity, are possible. To this day, the source of Martian methane is one of the world's great mysteries. Knowing whether or not methane is bioactive is important for determining whether Mars can support life. One of the current theories about life on Mars, if it exists, is hidden underground. The surface of Mars is bombarded by high levels of atmospheric radiation due to the thinness of the planet and the lack of a magnetic field. This harsh environment makes the surface an inhospitable habitat for life. But below the surface, life can be protected from these deadly rays. There is strong evidence that beneath the surface of Mars there is a pocket of liquid water that is protected from freezing by hot temperatures. In 2018, the European Space Agency's Mars Express rover discovered a large subsurface lake near the planet's south pole, which strongly suggests that Earth could host life. Future NASA missions, such as the ExoMars rover, aim to delve deep into the Martian surface to search for signs of life. Hopefully, by digging beneath the surface, researchers will find preserved microbial life, the remains of ancient organisms. The ExoMars rover equipped with a drill will reach a depth of 2 meters, much deeper than previous rover missions. NASA's Perseverance rover, which will land in Gale Crater in 2021, represents the greatest effort to find signs of life on Mars. Gale Crater was once home to a large lake and delta, making it one of the most promising locations for finding biosignatures, chemical or physical signs of life. Perseverance is equipped with a suite of instruments designed to detect organic molecules, analyze rock samples, and search for signs of past microbial life. One of the rover's key tasks is to collect samples for a future mission that will return them to Earth, allowing scientists to study them in greater detail than is possible with remote instruments. Moreover, Perseverance is testing new technologies that will be crucial for future human exploration of Mars. It carries an experimental device called MOXIE, which is designed to produce oxygen from the carbon dioxide in Mars' atmosphere. If successful, the technology could pave the way for human activities by reducing the need to import large amounts of oxygen from the Earth. The next big step in Mars exploration is the Mars Sample Return Mission, a joint effort between NASA and the European Space Agency. The goal of the project is to return the samples collected by the exaltation to the world, where they can be analyzed in modern laboratories. This allows scientists to search for microscopic fossils, study the mineral composition of Martian rocks and better understand the history of the planet. Returning a Mars sample is a great achievement, but it is also one of the most difficult. It consists of several spacecraft, including a rover, a small rocket to send samples into Mars orbit, and an orbiter to return them to Earth. If successful, the mission could provide a definitive answer as to whether Mars was ever inhabited. While robotic missions have provided valuable data, the primary goal of many space agencies is to send humans to Mars. NASA's Artemis mission, which aims to return humans to the Moon, will find a way to Mars. By establishing a permanent presence on the Moon, NASA hopes to test the technologies and systems needed for a manned mission to Mars. Sending humans to Mars presents many challenges from the technical and logistical to the psychological. A 6-month journey to Mars will expose the astronauts to long periods of microgravity and atmospheric radiation. When they go to Mars they encounter extreme heat, dust storms and a lack of resources. However, the benefits of human vision are clear. Unlike robots, humans can adapt, think critically, and make real-time decisions, qualities that are critical to the success of a more complex mission than Mars exploration. As we enter a new era of space exploration, Mars remains a beacon of hope in the search for life beyond Earth. Although the surface of Mars may seem barren and inhospitable, the evidence we've gathered suggests that it was once a very different world, a world where life could have existed. Whether it's finding evidence of ancient microbes, finding life hidden beneath the surface, or paving the way for future human habitation, Mars has the potential to answer some of the deepest questions ever. Ask us. The red planet, a symbol of aliens in mythology, is now a symbol of our own people's desire to explore, understand, and maybe one day reach the world.